Hello, everybody. Thank you for joining us and for tuning in to Payload's latest and greatest webinar. My name is Ryan Duffy, and I'm the managing editor at Payload and the host of our Pathfinder podcast. And I'm super excited today to be talking about democratizing manufacturing in the space industry. I'm going to introduce all of our esteemed panelists here in a sec, but first I want to thank First Resonance, our sponsor, for putting this on and making this possible. So thanks also to Karan, Tim, and Mallory for joining me today. I'm going to hand it over to each of you for a quick intro, and we'll start with Karan.
Wonderful. Well, it's great to be here. Hi, everybody. I'm Karan Talati, CEO and co-founder of First Resonance. At First Resonance, we are building the Ion Factory operating system, now used in about 4 dozen factories in automotive, aerospace, robotics, construction, and energy. So it's very exciting times. We're a startup based out here in Los Angeles. A number of our team comes from aerospace and automotive backgrounds, companies like SpaceX, Tesla, Apple, so on and so forth. And over the past few years, we have had the privilege of innovating and disrupting a space that very much needs to be. I'm excited to talk about that topic and how data and modern compute is going to power incredibly new and exciting things. So that's me.
Tim, we'll go over to you next.
Sure. Hello, my name is Tim Berry. I'm the head of manufacturing and supply chain at Launcher. We are a rocket and spacecraft manufacturer. We produce a orbital transfer vehicle and space logistics platform called Orbiter, flying for the first time on SpaceX Transporter 6 rideshare mission. Additionally, we build and operate a small launch vehicle called Light, that uses our E2 liquid rocket engine, which is the highest performance kerosene liquid rocket engine ever made in the US. We're based here in Hawthorne, California, about 5 blocks east from SpaceX.
And last but not least, Mallory.
Thanks, Ryan. Hi, I'm Mallory McLemore, and I'm the co-founder and CEO of Stell. Stell was founded only about 2 months ago, and it's based on my background as an aerospace engineer and head of quality. Stell is really like adding another supplier quality engineer to your team. And we're really focused on digitizing the engineering information, especially on the supplier side, which has really still been disconnected and largely offline. So excited to talk about quality and manufacturing and suppliers today. Fantastic.
Thanks, everybody. Before we hop in, I just flipped on the so everybody tuned in today should be able to send questions into me. So I would encourage you to do so if you have any questions for the panelists, and we will try to get to as many as we can towards the end of this conversation. So send them in, and I'll take a look at everything, and we'll try to tackle as many as possible. So I'm just going to read the sort of quick tagline for this, just to set a baseline. Competition and venture-based financing have pushed the pace of aerospace manufacturing. Therefore, gains in efficiency, time, and scalability are essential. Manufacturers must iterate from R&D prototypes through scaled production, and this requires a new technology stack designed for data and continuous improvement. So yeah, with that in mind, I want to start with my first question is how each of you think manufacturing has changed and is changing as the industry becomes more commercial, and we're seeing sort of the privatized, private players playing a bigger role in sort of every part of the space value chain. And we can start with whoever, and we'll go from there. Go ahead, Karan. I saw you unmute first, so we'll start with you.
I've been unmuted, but yeah, I'll that's perfect.
Okay.
Happy to that.
There you go.
This is a fantastic topic. So, and I know that we're all, everybody on the panel here is either grappling with this challenge, like Tim actually building hardware, and then Mallory and myself, powering what we think is the next wave by connecting some of these dots. I think you said it in the question there, Ryan. Business models have completely changed. I think companies like SpaceX, especially on the aerospace side, but many other examples on the automotive, so on and so forth, have shown that private investment and capital can actually disrupt major players, very wasteful kind of endeavors and entire kind of industrial complexes. Because that has been proven, now that's the bar, which is an exciting opportunity for those who embrace free market capitalism and competition and a lot of these dynamics that actually power a lot of the great kind of market dynamics that we all have as consumers, so on and so forth. But of course, that comes with great challenge. Just because we're going over to private investment and capital constraints and competition doesn't alleviate the responsibility for safety and kind of like quality criticality when it comes to these types of things. So whether you're launching a rocket or creating a new type of nuclear energy technology, right, and distributing it at broad scale to match that business model, it's hard. It's really hard. And I think the main observation that we've had is, while it's hard, there are incredible new technologies and possibilities of connecting the dots so that things don't slip through the cracks. Using data, using efficient compute, the cost of storage and compute have basically been decimated, and that would be an understatement over the last 10, 15 years. So how do we, meet the needs of these much more performant and efficient business models while maintaining the high bar for quality, criticality, and safety? I think there's opportunity there with employing the best of modern technology, such as data and compute. So that's just the tip of the iceberg. I know we're going to talk more on it, but would love for the others to share.
Yeah. Thanks, Karan. Mallory, we'll go over to you and then jump over to Tim.
Yeah, I really think about like the top line financials change. So the factory floor has to change because of this. So in like legacy aerospace and defense, cost plus contracts were really in place for these like exquisite large space systems. And so the factory floor was optimized heavily for risk and for like additional meetings, taking weeks to make a decision. And, data could be collected in Excel because you had, the time to make that decision was so long. And now the financials are all about operational efficiency. Like investors want to see return to capital, and launching quickly is key for competitiveness. So making decisions quickly, like having a data platform to do that, and really optimizing for quality, where it counts, and decision making where engineers are empowered, manufacturers are empowered. Like it's just the pace and I guess optimization has changed.
Great. Tim?
Yeah, for me, I think ultimately manufacturing has become a lot cheaper, faster, more directly tied in with design. That's both through like better engagement, I feel like, between the design teams and the manufacturing teams, but also due to the proliferation of collaboration softwares and things like that. So it could be back in the days where someone making a part had never actually met the design engineer, and that design engineer may even be in another state. So I think what's really changed a lot as the industry is commercialized is teams being a lot more integrated. I also think there's a big focus on process validation, which is something that's borrowed from the automotive industry. But more legacy aerospace companies are typically doing a lot of single piece acceptance, so 100% inspections, inspecting every part. Whereas in the automotive industry, they can't take the time to stop that. Like anytime the line stops, you're losing money, right? So I've seen definitely a trend towards doing more process validation and also borrowing more of the strategies that they use in the automotive manufacturing industry. Additionally, since the pace of manufacturing is becoming larger, more people or faster, more people are leveraging commercially available off-the-shelf components. I think there's a big downward pressure on BOM cost. A lot of space hardware is exorbitantly expensive. So with people improvements, making things faster, making things cheaper, I think there's been a lot of downward pressure on BOM and component costs. And finally, there's a big focus on reliability and training in the industry now. So as companies move out of development into more full-scale production of their products, I think there's a renewed focus on making sure your products are reliable, but also on adequately training and equipping your workforce to be the best possible.
There's a lot of great threads there to dig into that we'll definitely cover, but I think that sets the scene quite nicely for the rest of this conversation. I'm curious to hear from each of you what role data plays in this transformation and just generally pushing forward the scope and kind of quality and pace of manufacturing in this sector. And I'm using data quite broadly there. And so for this one, I will I'll if anyone wants to go first, just raise your hand, or else I'll call on someone, and then we can go from there. All right, Tim, I'm going with you first for this question.
All right. So I think data is essential to reducing the inspection and qualification burden of hardware that you produce. Like one great example is in-process monitoring for 3D printing or additive manufacturing. So the ability of the printer at the end of the print to basically give you a report that says everything that happened in the print, whether there was any anomalies or there might be any defects present or anything like that. So I think data is helping to streamline inspections, collect trace and reliability data, and ultimately helping to reduce the number of inspections that are required in any product. I think also there's a better feedback loop, with the additional options available in terms of dashboards, data analytics, and things like that. I think there's more data available for managers, supervisors, engineers to make decisions and be able to make them a lot more accurately based on having the proper information that they need. And also from a quality standpoint, but also just a factory connectivity standpoint, there's more of a digital thread that kind of captures the life of the hardware. A great example is you can have a software that tracks powder when it leaves the powder manufacturer all the way through to when the component is eventually integrated into the end use. So I think things are a lot more connected, and data has made hardware ultimately more reliable and helped to streamline manufacturing as well.
You want to take the baton next?
Yeah, I'll build on Tim's point about quality assurance. Like, I think a lot about root cause analysis and quickly, as an engineer, being able to problem solve some kind of defect or delay in your factory or supply chain. Data is really the core to doing that quickly and accurately. And so I think that's one thing where if you're capturing like single piece flow information, serialized inspection results, that's when you can really start to unlock like predictive quality and solve those problems faster. And I also think of digital twin and connectivity, like not as a buzzword, but like as these companies want to actually operate space assets for their customers. And like you think about the full life cycle of adding software onto the hardware, like actually digitizing all of the decisions made to engineer something, not just geometry, but what was the supply chain, what was the process that went into that part, and being able to predict and kind of have this full life cycle twin of what you're operating is really key. And that's where a lot of companies are trying to differentiate now, is in the software stack.
I'll take it home then, and I'll start at the back. There's something at First Resonance that we quite often say is, why don't we have Starship Enterprise yet? This is all like where we're all going. Not just in a cool, fun, exciting way, but it's where we all want to get to. And if you really look back at the amazing boom of technological development since the Industrial Revolution, especially in aerospace, right? Like we went all of a sudden from thinking that humans flying at all was kind of like Leonardo da Vinci's like grand scheme, into having like full on 787s right in a very short amount of time, doing international travel. That's a miracle in many ways, but where have we progressed since then, right? And the pessimistic view here is a little bit that it's tapered off. So one thing that we believe here at First Resonance is that, with some of these data, applications, whether it's digital thread, whether it's serialized tracking, whether it's easier information exchange across the supply chain, data actually unlocks, I think, what seems to be kind of like a max of like human organizational capability. And the only way that we'll be able to actually get to something so large scale that we're, actors and players in a larger kind of galactic human consciousness is through having like an augmented co-pilot, if you will, and making these critical decisions around how do we refine our designs, how do we more efficiently move material or extract material to be fuel, et cetera. So agree with everything that Mallory and Tim just mentioned. I just took it a little bit more sci-fi, but we see this as being, if the Industrial Revolution did what it did in a matter of a few decades, the information era has the opportunity to do the same at a scale that's equally as exciting and kind of miraculous. And I think, it just starts with smaller, data. You layer on ML, you layer on kind of augmented decision-making. I think in aerospace, it's especially interesting because the criticality is high. So that's why I go back to augmentation, making decisions side by side with humans is probably how you do it. Whereas in, tech more commonly, a machine learning model that's 73% accurate could be good enough. 73% accurate isn't good enough in aerospace. So that's definitely something that we need to grapple with.
Yeah. I mean, I totally see that. It's a different sort of standard within the worlds of bits and atoms, even though as we've kind of already hit on, that's like not necessarily, it's kind of a false dichotomy in many ways. This is like the quintessential industry exemplifying how those weave together. I also appreciate Mallory, I appreciate you saying digital twin. Someone had to say it. We had to check it off of our buzzword bingo card. And then Karan, I appreciate the meta kind of ending on a meta note about augmenting human consciousness. And you also started, you in your last answer, you were kind of talking on a time scale of decades, and ties in pretty nicely with the next question, which is effectively, to what extent some of these trends, like so many of the pieces in motion that you've all already talked on, in terms of tighter feedback loops, like everything being digitized, like collecting data across the end-to-end operations, how you see all of this playing out over the next decade. So we are, this question very much is rooted in like decades long thinking. So just to add like a little bit of clarification there, kind of extrapolating off of your current answers, and then maybe some amplification or just what to watch for over the next 10 years in this sector.
I can get started on this one. I should probably answer in terms of like commercial space stations or hypersonics, but I really think about aerospace software as being for the people that use it. Like, most of the engineers in the US, they come from state schools. They go to small suppliers or big OEMs, and like, I think a lot about what is their day-to-day like right now. And I think still it's a lot of paperwork if you're not in Silicon Valley. And so we're training these engineers, and then they go and they do 80% like filling out a defect report or like searching their manufacturing system for information. So if we want them to be building like new energy systems, like exploring the galaxy kind of tech, we have to give them new tools, and we have to get people excited when they're 22, 23, they come out of school with this engineering education, like they're immediately spending their time thinking about and building these kind of critical technologies.
Yeah, I'll hop in. I couldn't agree more with that. And the great news is that we have some of the examples just, in the past like 10, 15 years. AWS allows, somebody with an idea in a garage to bring up an entire, kind of global scale information system. That's pretty amazing. You know, these API driven kind of companies like Stripe or Plaid or Twilio basically puts the power of telecommunications or something as complex and regulated as financial payment processing. I mean, this might sound boring to a lot of the audience here, but hopefully not. You know, the exciting thing is, you know, I think to reflect on what Mallory said, you know, when we think about Starship Enterprise, why don't we have Starship Enterprise here? The persona that we kind of revolve around is Scotty. I'm not a huge Trekkie, so apologies if I mess anything up here, but, you know, putting a tablet in one engineer's hands to figure out a critical engine failure very quickly, like getting that information, again, like skewing into sci-fi, but it all starts with these small kind of like tools that have great interfaces that can actually speak with one another. This is the building blocks for just having faster access to information. When you have faster access to information, you have faster ability to resolve these kind of paperwork, kind of manual labor kind of things, even though they're knowledge work. You know, we quickly need to upgrade from that. We need to go to creativity work, where you can actually spend the time, you know, putting together the pieces for where we need to go, not just what we need to maintain. So yeah, I think, you know, very excited about tooling. You know, it's the unsexy, boring things, APIs that power highly regulated things on the back end. But really what we think about is, yeah, the same way that you could go to Silicon Valley and walk into an engineering office and see people calling multiple APIs, stitching those together for a higher level application, so that people could live better. I mean, the prospect of that when it comes to aerospace exploration, energy, environment, that's just massive. Yeah, couldn't be more excited about that.
Yeah. So over the next 10 years, I think data will continue to streamline the teams that we have, right? You know, oftentimes when you go to some manufacturing facilities, you'll see technicians that are either still filling out paper forms or are doing like 1,000 clicks just to buy off like a simple torque or something like that. So I think the ability, the data collection and the streamlining of the access of data is going to ultimately make technicians, machinists, asset-based labor more efficient. Also, from an additive manufacturing perspective, you know, the increase in data will allow better process monitoring and automation tools, even to the point where you know, a turnover on a 3D printer could be done autonomously, and then the parts can be transported through post-processing and then delivered to a machine for subtractive machining. So I really see data ultimately streamlining manufacturing operations, both the way that humans interact with the data and with the factory operating system, but also the way that we track parts and how things move through the value chain. And also data ultimately, I think, will yield better performing teams that are more connected, people that aren't siloed or you know, just feel like they're compartmentalized away from each other. The free sharing and flow of information and collaboration, I think, are going to ultimately yield better performing teams and a better work environment for people that feel more connected with their teammates.
That was all great. I mean, honestly, if I have one little mini takeaway, so from that question, those answers specifically, it's like the tooling and the underlying infrastructure may be unsexy, but that's what makes the world go round. Maybe on the flip side of that, my next question is sort of what technology underlying or foundational tech advancements will be the true game changers. And I think that we've already definitely started dancing around this topic, and like, you know, Tim, just in your last answer, you know, the role of 3D printing and additive manufacturing, for example, but I'd like to more explicitly zero in on that and just discuss like the various technologies or systems that either are coming online or are right around the corner, that will push the envelope forward. Karan, you're unmuted again, so I'm gonna hand it over to you.
Well, yeah. Okay. Awesome. You know, we just talked a lot about data. I think machine learning. So actually, just some quick context here. Between being at SpaceX and kind of like my aerospace life and getting fed up with some of the paperwork and bureaucracy and things like that. So fun little Karan anecdote here. I ran away from aerospace and manufacturing entirely. Thought I'd never be back, and was excited for the world of tech and all the things that the bits and bytes were doing for the world. Clearly, I came rushing right back, and that's a story for another time. But nevertheless, observing what has happened in the development in just the past 10 years of big data into machine learning, into kind of the hype areas of like AI, and how this is kind of pendulum swinging back and forth is pretty amazing to see. There are some really amazing developments in kind of the AI kind of information communication space. Some of you may have kind of been playing around with Chat GPT over the past week or so. What opportunities does this open up for conversation on the factory floor? Again, going back to that augmented kind of conversational approach to being more creative. But machine learning in particular, I think there's some statistics out there that manufacturing is one of the highest producing sectors of data. Unfortunately, a lot of that data is locked away in kind of hierarchical structures and file folders. There are technologies like robotic process automation that can actually unlock that and surface the right data by kind of synthesizing across and looking for shared patterns of what data is relevant. And then, putting up machine learning to look at, something that, historically manufacturing has been this process that you wanted to really hone in on process consistency and reliability. It's a topic that Tim talked about a little bit ago. A great example of this is the Toyota production system, right? And how manufacturing is done using very predictable and kind of like process constrained types of ways. Machine learning, however, kind of unlocks the ability to bring more flexibility and maybe even less information and standards and process into the environment, and get probabilistic kind of nudges towards the right answer, right? Hey, you might want to take a look at this, or this seems anomalous, without having to do all the manual work of actually detecting, anomalous data, or setting up all of the inputs and sample size that's required for something like, statistical process control types of approaches. So I think machine learning is something that we're definitely excited about. And, that's just from the digital side. I think when you layer that on with technologies that Tim just mentioned, getting a lot of, that's really, really cool stuff.
Tim, I think that flows kind of naturally into what you were just referring to. So we'll hand it over to you.
Yeah, I would also agree with Karan that the machine learning is going to be an incredibly paradigm shifting technology. I'll use another example from additive manufacturing, because it's near and dear to my heart. But there's companies that are developing smart machines essentially that can have an instantaneous feedback loop that's connected with their process monitoring. So they can do things like slowing down the scan speed of the lasers, or automatically ramping the power up and down based on the thermal input. So I think with the maturation of machine learning, it is going to be a huge unlock for anyone that's doing additive manufacturing. And then just on the actual like rocket and launch side, because that's obviously where we come from, I think a couple other tech advancements that are going to be big game changers are going to be widespread rocket reusability. So, more companies adopting the SpaceX method of recovering and reusing the boosters, and also increased and cheaper launch infrastructure. So not having to necessarily go to the one launch pad that has 50 customers waiting to launch from it, or having to fork out the money to buy your own launch pad, but having a lot more flexible, scalable, cheaper, and available launch infrastructure, I think is going to be a huge game changer, at least for our industry.
And Mallory, what are your thoughts from where you sit?
I'll get more into the nitty gritty because I like the word machine learning, but I kind of I feel like we're not quite there yet for a couple of reasons. So I get excited about inspection data in the factory. So on the machines, CMM data, actually being collected on parts and then integrated into a system, optical inspection data, so taking images of parts or 3D scans, and then actually uploading that data against some kind of software object where it can be tracked through the life cycle of the part. What happens right now is a lot of quality data at the machine or in the quality inspection room becomes a PDF and is sent, into the ether. No one ever reviews it. There's so much information that we're leaving behind when we have paper travelers with parts. So I'm really looking forward to seeing all of the kind of quality assurance and equipment startups that pop up and have great APIs and connections to give that data back to OEMs like Launcher.
I can already see in the chat that the paperwork comments and the permeation of kind of still relatively analog practices it resonates and it's resonates with folks. I'm actually going to take I'm going to take a question right now from the audience, because it relates to the thread that we were just touching on. What is, and this is from someone I think it was just sent a few minutes ago. In your opinion, what is the most underexplored application of ML in the space industry?
Yeah, I'll take a stab at it. Because this is something that we're actively working on. I think it's just anomaly detection. It's a really simple use case. So actually reflecting on Mallory's point, where this is getting into the nitty gritty as well. I think some of the developments in machine learning over the past few years, such as neural nets, they've required a large scale of data and a very kind of I would say computationally reckless approach at applying it. But there's other, very much simpler kind of just even linear regressions, random forests, type of technologies that can just help you find things that are inconsistent with the things that you've observed before with a really small sample set, actually. That difference between, kind of the approach, the historical approach of golden unit, and then go find your anomalies or off kilters from there, or just doing in family manual kind of eyeballing. There's a nice wedge right in the middle for unsupervised anomaly detection that is a machine learning technology. So yeah, that's one example.
And just to expand on that, in this industry compared to others that might be using the latest and greatest in machine learning, sure, things are that the volume is increasing, but we're still talking about a relatively limited amount of vehicles or rockets that you're making. There's not the same scale of data. Is that right? Is that similar to what you're saying?
I actually disagree. So
okay, good.
This is where things get interesting. The reason I disagree is not because of any of the points that you just made. In that, let's say for every one rocket, and this is completely arbitrary, I don't know the true ratio. Let's say there's 1 million iPhones, right? One rocket, 1 million iPhones, and therefore you have more data. That's actually not necessarily true. When you start collecting all of the individual and very discrete number of bomb items that are under that rocket in line and in the process, right? So random example, for every one rocket there might be 9 engines, and for every one of those engines there might be 3 engine controllers, right? So now all of a sudden for every one of those engine controllers you have multiple boards. So the entire process, and I think Tim brought up the example of actually doing powder tracking even from a source. When you bring more data from outside of the walls and start joining data, you actually have a tremendous amount of data. Again, that statistic, I don't know the exact statistic. Manufacturing is one of the highest producers of data. It's just unfortunate that most of the value of that is locked away, and that's the big gap that I think we can unlock just by diving into the manufacturing process and not just looking at what happens post-delivery, post-production.
Mallory, any thoughts here?
Yeah, I think I'm interested in data in kind of a less sexy area. So in supply chain, I think lots of people don't want to go into manufacturing right now. And it's really, really tough to run a smaller shop or supplier. You're constantly under pressure from the OEM. And I think things are shifting right now. Everyone's wanting to reshore, suppliers are becoming empowered. And so I'm very interested in data, which allows suppliers to really get paid for the good work that they do, and then be able to like reinvest that in their workers and equipment. I think that we'll see huge gains in what we can do with manufacturing if we can start to capture who's really performing the best in the supply chain and like how do we reward them financially for that. I think right now, because everything is so disconnected and the data is so siloed, it's so relationship based. It's like, hey, I know this guy down the street at this shop. Let me Google the part that I want to buy. And with that limited data set, like how do you really reward the winners that are innovating and kind of making gains, you know, in the factory? So that's what excites me about data.
Yeah. In terms of machine learning being underutilized, I think one particular area is in predictive maintenance. So, you know, there's a lot of companies have preventative maintenance programs and things like that, where they're periodically, you know, taking down a machine to service it, change out parts, clean it, anything like that. Sometimes those things are done on a cadence where, you know, one time you at a 6-month PM, you check it and everything's like totally fine. You didn't even need to do it. At another 6-month PM, then you check it and you have to replace a bunch of parts. So doing the set schedule, I don't think is the smartest way to do it. I think machine learning plays a huge role in things like, I'll give an example of a CNC. So if you can have machine learning software that's smart enough to know your spindle has been running at this speed, at this temperature for this long, it needs to be replaced, or you need to fix something else somewhere else in the machine. And it can predict when a problem might arise or when maintenance might be needed. I think it'll ultimately trim down on the amount of maintenance that has to be done and improve the availability / utilization of those machines as well.
I think Mallory touched on talent. I want to circle back to that. I think that's really important, and I've seen some questions already in the audience related to that. But just to cover our bases, I also want to ask somewhat unrelated to what we've been discussing, what everyone's thoughts are on whether this space will become, you know, commoditized or somewhat commoditized.
Can we define the space? Oh, sorry. Just wanted to
no. Go ahead.
Yeah. So which space? Are we talking about the tooling? Are we talking about the applications? That would be helpful.
The tooling. Thanks. That's good to clarify.
In terms of like software tools or like actual factory tooling, or
pick your poison. I mean, if there's some parts that you do, I mean, maybe we could tackle this from the spectrum of what is most likely to become commoditized.
I think for myself, when I think about that question, what immediately comes to mind for me is companies that manufacture, in-source manufacture most of their own hardware themselves. And then they can demonstrate it on orbit, iterate, they own the design, they can improve it. And then ultimately when they demonstrate that their designs, are able to function with whatever the mission requirements are, then they can, kind of parse off those components and sell them in as their own commodities, more in like a business to business fashion. So I think like as eventually it'll become very common for, even competitors to be buying components from each other or leveraging each other's strengths, given like the large amount of capacity and large industry that's needed out there, maybe less of a famine mentality and more of a rising tide lifts all boats mentality. So I definitely think the space will become commoditized from my perspective.
I think on manufacturing and operations, maybe in the last 3 years, you go to a conference and everybody talks about small distributed satellite systems with COTS hardware and a software platform on top. But to me, I think, how do they differentiate over the long term with launch costs extremely low? You need to have unique hardware going through your development cycle from R&D into manufacturing to be able to differentiate. Like, I think hardware in space will continue to be how you win. But also, like, you need to be able to execute on that. So having the right manufacturing systems and differentiating in your speed from R&D into production into launch, will continue to make the winners in this industry. And as far as enabling software, I think consolidation will take place, but right now it's going to be really healthy for the space and defense companies as all these software companies like Stel and First Resonance come in and compete and try to innovate for these companies. I think it's really healthy, and I don't think this software should be vertically integrated. An engine company should make an engine. Like, that's what they should be best at. And, they should go out and purchase software off the shelf, which will continue to iterate in the background on the things that the whole industry can benefit from.
Yeah. I really like, some of the points that Tim and Mallory just brought up here. I'll kind of, oftentimes we pattern match, but we're also very careful about overly pattern matching. But again, I think especially as the digitization of this is happening so close to the last boom of, the cloud era, there's a lot of really good examples right behind us that we can kind of project to. So, I'd love to kind of share a few examples here. It wasn't that long ago that Word and PowerPoint had a very deep moat. Microsoft Office was something that was sold, for probably way too much at, CompUSA. I'm sure some people might even have some discs laying around. But, like word processing, presentation development, even spreadsheets have definitely become more commoditized or accessible through, what Google has done, Notion, so on and so forth. So that's an interesting thing to take a look at, is like, even then you still have brand names. There's no like utility that provides something as simple as word processing, right? There's just better and improved user experience, accessibility, kind of like you could even equate some of these things to being like a reflection of what we call in manufacturing a supply chain. But the difference between Google Docs and Word is that you can immediately share and collaborate with somebody. And that's actually like a pretty big, jump from what a desktop-based software would look like. Now, a few other examples, and hopefully these are welcome, right? But like, everyone knows about AWS, and when it comes to data systems, it's a very powerful service. There are obviously competitors that have entered now, Google and Microsoft with Azure and Google Cloud respectively. I think people didn't see it coming, but companies like Snowflake that manage data at like a very high scale and also have their data cloud product is a true SaaS. That has a big brand that actually might even use AWS under the hood. I'm not exactly sure, but I wouldn't be surprised. That add layers of, again, user experience and kind of the human understandability of what data and applications there are that tell me that, these things won't necessarily be commoditized. And even if they are, it's still like decades out, just as like cloud software companies have not completely commoditized into infrastructure that's provided by only like three companies: AWS, Google, and Microsoft, right? I do think that final few points here. I do think that UX will be commoditized. I think common kind of project management tools, what used to be a big Kanban board, a physical one, has now gone onto like Microsoft Project, has gone onto like either like Monday or Airtable or things like that. The elements of how people move around timelines and take notes and share and @mention and things like that, that's coming into every software package, and it's table stakes. I agree with Mallory that consolidation will happen just as it has in the cloud. But to her point as well, we're kind of in this Cambrionic explosion that all of a sudden there are companies that care deeply and come from these verticals that so critically need a lot of synthesis across great modern UX, ability to scale in the cloud, and then what is supply chain when applied to standards in aerospace. That takes a very unique kind of sharp approach, and I think Mallory is right in that the only way that this entire industry, because at the end of the day, you have a whole bunch of new hardware companies like Launcher, companies that are up and down the street as well. And then you have software companies. But let's not forget the real enemies are the ones, that have had their buildings in these areas for decades. And are really not like moving things forward sufficiently enough. And that exists both on the software and hardware side, I would say, right? So it's really cool what's happening right now. There's this very exciting collaboration that's happening between new hardware and new software, that even in our small numbers, I think because of our small numbers, we'll end up pushing the world forward in innovation. It's going to be a journey.
How do you make do with the fact that, as we're thinking about talent, like to Mallory's earlier point, I think there is a lot more excitement and demand for manufacturing in the States than we've seen in a long time, like definitely since like before I was alive. A lot of us are alive. But and even though there are more folks that are excited and that they're bent on going into this, we're probably still, when we're looking at talent, we're going to be in a supply constrained world for a while. And of course, as each of you have discussed, like automation kind of changes the equation a bit, but only so much, right? Like you need people with you need the right knowledge networks and all of that. So how have each of you grappled with that in your past jobs and from where you sit currently? Tim, let's start with you.
Sure. Yeah. I think we have, we get the benefit in the aerospace industry, or especially as a rocket or spacecraft manufacturer, of people. There immediately being a spark from people that are interested in space, and being a lot easier to have talent find you than, say, like a smaller sub shop or something like that. So I think for us, we definitely get a lot of applicants and attention. I think we also find a lot of great talent. I think a lot of universities have done a great job of standing up student rocket programs to really help proliferate these skills out through the industry, and also allowing them not only to do like theoretical or propulsion analysis, design, anything like that, but also go out and get their hands dirty, make hardware, launch it, test it, try it, break stuff. So I think that trend, which needs to be a lot more widespread, but has helped us recruit engineers that have experience both like producing hardware, have a love of manufacturing, and are also really talented propulsion design, avionics design, or any other discipline as well. So I think there needs to be more of that in schools, but also more engagement with both old and new space companies to get people down to the manufacturing floor and really give them the opportunity to fall in love with it, with whatever industry they end up going into, and having an appreciation for turning something from a concept or a design on paper into an actual real piece of hardware. So I think like I said, we've had the benefit of being able to recruit and getting a lot good stream of candidates just by the nature of the things that we make and manufacture. But I think starting earlier, especially in the universities, with getting people more acquainted with manufacturing, will ultimately yield a better talent pool for us long term.
Go ahead, Mallory.
Just to build on that, I mean, I come from old aerospace, I guess, and there's nothing like, seeing the cockpit door on the airplane you built in person and knowing that protects people, or like an anti-ballistic missile system, and going on the ship with, the service members that operate that. Like aerospace and defense, I think these products are meaningful. And even if you're working in a machine shop, like these are good, like well-paying jobs that are steady, like great opportunities. And I think if we're seeing growth at the top level of the industry, they'll become even more attractive as employment opportunities. And I think in terms of talent, like for me, manufacturing is problem solving. So no one day is like another, and that's kind of the infectious energy that I love. And so you don't need this exact fancy degree in electrical engineering. Like if you can just come in and break down a problem and you're curious and you have energy, to me, manufacturing is a great career for you, and you're going to thrive. Like I never know the exact tech of a system when I join a company, but I learned, and everything is so specific. So if you just have that right attitude and the way you break down problems, like manufacturing is a great career. And so I think if we can communicate that and continue to de-paperwork the industry. Like it'll be great, and I think easier and easier to bring in talent.
Yeah, I agree with all those elements. I think, on the top end of things, there's this kind of pessimistic existential crisis that we have about what is the state of our industrial base, and with a lot of the generational turnover, will it crumble, and is it already crumbling, right? Yeah, that's a bleak thought. I think what keeps me going is in reflection of exactly the topics that we just talked about, which is how do you give people superpowers and help them really understand that? I think I still remember the rush that I got going to my first hackathons back in college, and getting a website to do this one thing. I mean, that was my era. I think what Tim is bringing up has been an amazing thing to witness, is when we go into some of our customers' factories and we see some 20-some-year-olds whose hackathon was some of these rocket versions of that, right? Like going out to the desert and hanging out with friends. I mean, that gives me an incredible amount of hope. I think once you get into the workplace, it's like, how do we extend that further, right? How do we give people superpowers such that they can practice their creativity? Just to be controversial and throw perspective out there, in light of a potential economic downturn, a lot of fluff and excitement over shiny technology is going to wash out. And those skills are there to apply towards the most existential and honestly, hopefully here soon, the most sexy applications. I mean, what's cooler than a 3D printed rocket? What's cooler than an electric airplane that beats traffic? And being able to just do a little bit of this and that, and kind of minority report your ability to make those things come to life. I mean, that's going to be awesome. I'm jealous of the future generation if I think about it like that.
Yeah, I think the building cool stuff. I don't know. I don't think I'm supposed to curse on these. I think building cool stuff will be a powerful recruiting tool, and that's not going to change. And that's great to hear a lot of reasons to be optimistic. Switching gears a little bit, and this is another one from the audience. Would increased transparency and digitization in hardware supply chains reduce the trend toward vertical integration? So in other words, kind of level the playing field, or would it make vertically integrated companies even more efficient at sourcing parts internally, like bringing everything in-house? And I would add, I guess, entrenched. I think that's an interesting question that would love to hear everyone's thoughts on.
Yeah, I'll go first. My opinion is, I think there's a lot of not easily quantifiable benefits to manufacturing the vast majority of your hardware yourself, right? Like you don't have to iterate design someone else's design, which they don't want to change because they have a lot of other customers that buy it. Schedule considerations, right? A lot of shops don't work the same hours as aerospace companies do. Even if your hours are reasonable. So like if you need something done over a weekend, or hey, you have to drop it off by 1 p.m. on Monday or Tuesday and that's it. Otherwise you have to wait till next week. So I think the trend of insourcing is going to continue no matter what, of people wanting to own their own destiny, make things in-house and be able to operate hardware rich and iterate quickly. I do think that additional pricing transparency and the availability of data to know that a part that was made, supplier quality, and a part that was made somewhere is good when it comes in and when it's shipped from the manufacturer. So there's less wondering if it got damaged in transit or if it was made incorrectly or anything like that. I think that will promote the use of more sub shops and help them to grow their business in aerospace as well. There's always going to be those corner cases where you have a very large part that you have a very small demand quantity for. So you don't want to buy a $6 million machine to make one part every month or something like that. So I think those opportunities will always be there. And then the shops that do end up taking on that work, I think would benefit a lot from additional transparency and digitalization. But I don't think that anything is going to slow the kind of trend of a lot of companies to insource, especially for people who throughout their career have kind of had that burned into their brain.
Yeah. I have kind of a hot take here. I don't think vertical integration will take place as much as we think it will. I think at the time SpaceX came about, it was very efficient, and solving for transparency and reliability in the supply chain had to take place. But is solving for those things worth like buying all of that equipment and kind of, you have to boil the ocean, right? Like, what are you really good at that point? Like, you have to solve for all of these engineering and technical challenges across hardware that is so complex and specialized. Like, to me, the guy in Montana that can perfectly grow the crystal bull and then machine like, the infrared glass, like, he's the person that should be doing that. And these companies should be buying from that specialized person with transparency and data in place versus trying to bring that in-house and recreate it where it's not a top priority. So innovation being specialized actually, increases the speed at which we see, commercial space stations and hypersonics. Airbus and Boeing, weren't vertically integrated, or they were vertically integrated at first. And to be competitive, they outsourced more and more of their things until, now they're basically a system integrator. And I think market forces were like that for a reason. I think we'll start to see that in commercial space.
Yeah, hot take was the words that I was going to use, Mallory. So I'm glad that we're busting out the hot takes for the end. It's really interesting. I'm grappling with this. I think I'm still developing my thoughts on it, because even extending off of what you just brought up there, Mallory, there are plenty of examples of where that active horizontal integration has been very costly, like the 787 program, for example. That being said, that's not to say that there's no place for horizontal integration. I'm actually a big fan. I think what it kind of comes down to is vertical integration versus horizontal integration is really dependent on, like, it's a strategy, and that strategy needs to be right for that company, and that company taking on any one of those strategies needs to be capitalized to the right amount. Elon Musk, this is my hot take, interesting character for sure, but whatever it is, came in with millions and millions of dollars with friends with billions and billions of dollars into something. And I think that if you can leverage that could be a fine strategy. I would caution people to not be so black and white about it. I think, to actually, Tim kind of touched on this, I think when we talk about vertical integration, or a modern form of vertical integration that people really should embrace, is information and speed vertical integration, right? It's not about the material. It's not about the metal. You could have a shop halfway across the world that'll give you a quick turn on some super specific material way faster than you can produce. And that's actually what you should be going for. So I think, it's not so binary. And as the world continues to become more and more digital, I think, again, looking at the digital pattern matching is very important. If you're thinking about a company like Uber, you could think that it's, somewhat vertically integrated, but it's actually very hard to disambiguate. Like, is it actually? Gig economy, so on and so forth. But even the underlying technology, I brought up the example of Twilio earlier today. When anybody gets a text message or a phone call from their Uber driver, it's actually, hitting that API, or at least I still think it is. So it did at one point. The point is, I think the winners are going to be the ones that choose the right strategy, aligning that to their capital, and actually making very nuanced decisions about what to vertically integrate. That might be more in the digital and information layer, and what to, what to go out of house on. And I think those are the true winners, are probably the ones that don't look at it like you need to drill your own oil in order to build an airplane, right? So yeah.
Well, Karan, I think a lot of the analogies that you've been making, like to AWS first and foremost, but then to a lot of these other tech companies, like, come naturally and are fitting, because the whole topic here today has been democratizing. So that's my final 2 cents. But we are unfortunately out of time for today. I want to thank First Resonance for making this possible and help putting this on. And I want to thank Mallory, Tim, and Karan for giving us some time out of their busy schedules. For everyone else, just a final housekeeping note. This has been recorded, and we will send a link out to everyone who attended. Thanks to all of you for attending. Thanks to those of you that wrote in with questions. I'm bummed because we had a bunch of a bunch of great questions that we weren't able to get to, but maybe we could save that for a part 2. That'll do it for today though. And hopefully we will see all of you back here soon for another webinar. Thanks all.
Thank you.
Everyone.